In the previous video, we have seen that some of the difficulties in the root array. If there exists a element in the first column of the root array, hence the system is unstable. In order to calculate the roots in the right half of S-plane, we have two methods. First one we will see, okay, we will understand that by problem, okay. By means of Routh criteria, determine the stability of the system. For the system found to be unstable, the system, if you found unstable, determine the number of roots of the characteristic equation, the right half of S. If the system is unstable, we have to find out how many roots are there in the right half of S plane. Okay. The given equation is given characteristic equation is s raised to 4 2s cube plus 20s square plus 20s plus 5. Okay. How to draw the root table? Okay, we have to, in the first column we have to keep from highest order to lowest order. Okay, from s raised to 4, s raised to 3, s raised to 2, s raised to 1 and s raised to 0. Okay, s raised to 4 is 1, 10 and 5. 1, 10 and 5. In the second row, second, fourth, fifth elements 2, 20. Okay, and here it is not there, means 0. Okay, how to calculate next s square columns, s square row, by considering above two rows. Okay, that is 2 into 10 minus 1 into 20, that is 2 into 10 minus 1 into 20 divided by this 2 value. Okay, here we will get 0. Okay, for the next we will have 2 into 5 minus 1 into 0, that divided by 2. Here we will get 5. Okay, here there exists a 0 in the first column of Routh array. Okay, so the system is unstable. Okay, there exists a 0 in the column, in the first column of s square row, so the system is unstable. Okay, in order to find out the number of roots in the S plane, we have two methods. First method is, we have to replace that 0 by a small value. We have to replace this 0 by a small value, that is epsilon. Okay, in place of 0 we have to place epsilon. So see here how it is, s raised to 4, s raised to 3, same as it is, 1, 10, 5 as it is, 2, 20 as it is. In place of 0 we have to put epsilon, and 5 as it is. In place of 0 we have to put epsilon, 5 as it is. We have given that. Okay, next, how to calculate next s raised to 1 row? By considering above 2. So above 2 rows. Okay, epsilon into 20 minus 2 into 5, that is 20 into epsilon minus 5 into 10 divided by this value epsilon. Okay, 0. And next value is 20 epsilon minus 10 divided by epsilon into 5 divided by this value. Okay, so this and this value will cancel, so 5 as it remains. So 5 we have given here. Okay, 5 we have kept here. Okay, this value is 0. Okay, next, how to calculate the roots is, put epsilon is equal to 0. Okay, 20 into epsilon minus 5 into 10 divided by 10, it is there now. We have to keep epsilon equal to 0 in this place. Okay, that is 20 into epsilon minus 5 by epsilon. Put epsilon equal to 0. So 20 into 0 is 0, minus 5 into 2 is 10, 0 is 0. Here we will get divided by 0 means infinity. So what is, if you put epsilon equal to 0, we will keep minus infinity. Okay, see, don't see the value epsilon or infinity or anything value, see only the sign. Okay, here we will have 0 minus 10, so minus infinity. Hence there is, see, plus plus plus, here from plus to minus and from minus to plus. Hence there is a two sign changes, from plus to minus and minus to plus. So there are two sign changes, means there are two sign changes, means there are two roots are there in right half of S plane. There are two roots are there in right half of S plane. Okay, okay, hence there are two roots in the right half of S plane of the system, and the system is unstable. Okay, and one more method is alternate method is put s is equal to 1 by z. In that equation we have to put s is equal to 1 by z. So in the given equation is s raised to 4 2s cube. In the place of s we have to keep z. So we keep like this and we simplified that. 1 plus 2z, 1z is missing. We have taken LCM, z raised to 4 2z plus 10z square plus 20z cube and 5z raised to 4 is equal to divided by z raised to 4. That z raised to 4 we have taken here, so denominator becomes 0. So we have to keep from higher order to lower order and rearranged this above equation, that is 5z raised to 4, 20z raised to 3, 10z square, 2z 1. We have rearranged that one. Okay, and after calculation is same as that of s plane. Z and s plane are both are same. Okay, we have to keep then we have to draw root array of this one. Okay, how that is z 5z raised to 4, 20z cube, 10z square, 2z plus 1. Okay, it has to start from z raised to 4. Next root array table, z raised to 3, z square, z raised to 1 and z raised to 0. Okay, in the z raised to 4 we have to keep same as that of s plane. Okay, first and third last 7. Okay, 1 5, next third one 10 and 1 as it is. In z raised to 3, say in second row we have to keep in second and fourth element, that is 20 and 2, 22. Okay, that is. And after calculation this one 20 into 10 minus 5 into 2. Okay, that one divided by 20 and 20 into 1 minus 5 into 0 divided by 20 we have given. Okay, next we have got after simplification of this in 9.5. Here you one. So after getting 9.5 we have to calculate next one, 9.5 into 2 minus 20 into 1. We have got this value, and after that minus 1.05 into 1 minus 9.5 divided by minus 1. We have 1. Okay, in order to calculate the stability of the how many roots are there in the system, here we have see plus 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 to minus. So plus to minus and minus to plus. Hence there are two roots are there in the right half of S plane. By taking these two methods, this Z transform method is very comfortable. Okay, we have to see how many roots are there in the Z half of S plane. Okay, hence there are two sign changes. Hence there will be exist two roots are there in the right half of S plane. Okay, thank you.